Here we just have a page where we're looking at the formula for R, the correlation coefficient. We're not going to ever have to calculate this by hand. Maybe in another class you might do that in the future if you have to take more statistics, but probably not. But here's the formula for R. We'll use StatCrunch to calculate it, so don't worry about making the calculations with this formula. Let's look at it kind of a little closer. So R is the sum of all, that's a complicated one, yeah, the sum of, you're multiplying these two things, whatever they are. This is the standard deviation for the X values in this denominator, the standard deviation for the Y values in this denominator, the mean of all the data values for the X's, or sorry, each X value minus its mean. So it kind of looks similar to formulas we've seen before. You take each X value for these data values, subtract the mean of the X values, and then divide it by the standard deviation of all the X values. Do that a bunch of times, and then also same with the Y values. Take every Y value, subtract the mean of the Y values, divide it by the standard deviation. We're going to do all that over and over and over for all the data values and then add them together. Once you add them together, then we divide by n-1. That's a complicated formula. That's why we have technology, thank God. Back in the day, they used to have to do that by hand every time. Oh man, that's a bummer. Even though we will not make calculations with this formula, we can get a good sense of what R measures by analyzing the formula. First, in this formula, the points in the scatter plot are X, Y. We use every point in the calculation. That's why we have this sum. It means run through every X value and subtract it from the mean of all the X values, and then divide it by the standard deviation of all the X values. Okay, now run through every Y value and do the same thing for the second part of the formula. Notice that the formula involves measuring the distance of each X coordinate from the mean of the X values. That's what this numerator is, X minus X bar. And this distance is divided by the standard deviation of the X values, S with a little subscript X. This tells us how far X is from the X mean in standard deviation units. In essence, we are measuring the distance from the mean with a standard deviation as a yardstick. We call this a standardized score. So it kind of looks like the z-score formula. Remember that? It was z is X minus mu over sigma, where mu is the mean and sigma is the standard deviation. That was if we only have one set of values here. Now we're trying to compare X and Y values to two different categorical data sets. So it's more complicated, but it's kind of similar to that. We're trying to standardize the data, which is what we did with z-scores. Also, we do the same thing for each Y coordinate. For each data point, the standardized score for X and the standardized score for Y are multiplied together. So for every ordered pair you have, you're going to calculate this, what's in these two parentheses. And then the formula is an average. We add up the products of the standardized scores and divide by n-1, where n is the number of data points. It's good to know that R depends on means and standard deviations, because this will help us understand some of the properties of R.